So we'll start revision. This will be revision for both 0620 and 0972, both codes, according to the syllabus. So I'll go through the syllabus as well as I'll revise the topic. The syllabus content are same for both 0620 and 0972. The only difference is the grading system. So the particulate nature of matter, experimental technique, atoms, element, compounds, stoichiometry, electricity, chemistry, chemical energetics, chemical reaction, acid-base salts, periodic table, metals, air and water, sulfur, carbonates, and the last one is the organic chemistry. As you are giving an extended part, because if you are giving a core, so maximum grade, as you can see, the candidate who are studying the core subject of the content, they will get the maximum is C. But as you are giving the extended one, the maximum is A star to G. So paper 2, which is about 30% of your syllabus, paper 4 it's about 50%, and paper 6 is about 20%. So the first content, the first topic, the particulate nature of the matter. In this topic, you should understand the distinguishing the properties of solid, liquid, and gas, describing solid, liquid, and gas, describing a change in state in terms of melting, boiling, evaporation, describing a pressure and temperature of a gas in terms of motion of particle, shows an understanding of a random motion or the Brownian motion, and explain diffusion. And these are the supplement part, means in detail what you should do. So chapter 1, the particulate nature. The distinguishing properties, this sheet is according to the syllabus. So distinguishing properties of a solid, liquid, or gas. That, as we know that there are three states of the matter: solid, liquid, and gas. Then how we can distinguish these solid, liquid, and gas? Solids, the particles are tightly packed together. The molecules are having a strong force of attraction between them. Where in a liquid, the particles are away from each other slightly. And for gases, the particles are far away from each other and moving randomly and spread apart. Then the second thing you can see, describing the structure like separation, arrangement, and type, the structure of solid. So this sheet is according to the syllabus. So changes of state in terms of melting, describing a structure of solid, liquid, and gas in terms of particle separation, arrangement. So particles, the gas particles have the most energy, and what will happen? The particles are moving randomly at high speeds. In liquid, the particle have more energy than of solid, but then compared to gases, they have less energy. And solid, they have the least energy, and the particles are basically motion is there, not moving from one place to another, and they are just vibrating. Then the changes in the state. What are the changes in the state? Evaporation is there when what happened when the liquid is changing into gas, but this happened when the molecules at the surface skip. Freezing when a liquid changed to solid, melting when solid changed to liquid, boiling, it happened throughout the liquid. This is also a liquid to gas. Condensation when gas to liquid, and sublimation when solid is changing into gas or vice versa. The changes explain changes of state in terms of kinetic theory. So what happened in terms of kinetic theory? The kinetic theory explain how melting, boiling, freezing, or condensation happen. What happened? The amount of energy needed to change the state from a solid to liquid and from liquid to gas depends on the strength of the force between the particle. If a stronger force is there, we need a greater amount of energy. If weaker is force between the particle, we need less amount of energy. The stronger force between the particle, higher melting and boiling point, and more kinetic energy to increase the temperature. The more movement and high cause of change in state, like from solid to liquid or liquid to gas. Qualitative means you don't have to mention a formula here. The pressure and the temperature of a gas. So what happens if high pressure is there, more motion of the gas particle will move faster, and higher temperature will be there. So means more motion of a gas particle as well. They will move faster. Then shows an understanding of a random motion of the particle. So what happened? The Brownian motion, the particles in a Brownian motion, the particles are moving randomly, continuously changing their direction. And this happened. Why this happened? Because the particles collide with other moving particles in the fluid. The term fluid means liquid and gas. Like example, if why the dust or the smoke particle does not settle down quickly. So what is the reason for that? Because this dust or smoke particle continuously colliding with the air molecule. So as it is continuously colliding with the air molecule, this cause a random motion of the dust particle or the smoke particle. And describe and explain the Brownian motion in terms of random molecular bombardment. That's I just mentioned now, that a particle in a liquid and gas, they move randomly because they are bombarded by other moving particles in the fluid. And large particle can move by lighter one fast moving molecules. And evidence of a Brownian motion, like Robert Brown observed a Brownian motion of a pollen grains within the water, and which showed that there were separate particles within the water that moving randomly and cause the random motion of the grain. Then the diffusion, the movement of the molecule from region of higher concentration to lower concentration, we call that as a diffusion. And what happened in diffusion? Therefore, diffusion does not occur in solid because particles cannot move from place to place, only vibrate. And a smell does not travel very fast because of the particle collide with air and changing the direction. When they collide, taking much longer time to travel from one place to another. Even there is a diffusion, but diffusion is not like particles just directly move from one place to another. They are moving, they're continuously changing their direction. So as a result, it will take longer time to move from one place to another. And the factors on which the diffusion depends: lighter gases, smaller molecules will have a greater rate of diffusion. They will move faster as compared to the heavy gases or heavy molecules. And rate of diffusion increases as well as the temperature increase, because when we increase the temperature, the particles will move faster. So this was topic 1, the particulate nature. Then what is topic 2? The experimental techniques. Name appropriate apparatus to measure a time. To measure a time, we can use a stopwatch, temperature by thermometer, mass by a balance, volume, which can be measured by a burette, pipettes, or measuring cylinders. Criteria of the purity, how we can check a substance is pure, how we can purify a substance. So topic 2, experimental techniques. These are some lab apparatus. A measuring cylinder is there. It is for approximate measurement of the liquid volume. A gas jar is here to hold the gas, but not to measure. Side arm tube is there, which pass through the liquid. Like if you want the substance to pass through or gas to pass through liquid, a pipette is there. It is used to measure the accurate volume about 25 cm cube usually. A burette is there. Maximum it can measure 50 and the smallest value it can be 0.01 centimeter cube. Pestle and mortar is there for grinding and breaking or to the solid into small particle. A Liebig condenser to remove the heat energy, condense the vapor. A gas syringe for measuring the volume of a gas. A flask with a side arm for filtration under reduced pressure. Because if you want the fast filtration, we use a Buchner funnel. Like we connect a pump here. A pump will remove the air. So when the liquid is passing through the filter paper, it will happen at a faster rate and the solid will be a dry solid. And a tap funnel is there if you want to, or tap funnel or separating funnel to separate the immiscible liquid which does not mix with each other. And the thistle funnel is there for adding a liquid to a flask and prevent a buildup of the pressure. So we use this thistle funnel if you want to add a liquid into a flask. Crucible tongs used to hold the crucible and a test tube holder to hold the test tube. A test tube is there, a boiling tube for heating a solid and liquid. A boiling tube is relatively bigger, larger as compared to that of a test tube. Beaker is there for holding a liquid. Conical flask for holding liquid. And what is the advantage of conical flask over a beaker? Because using a conical flask, we can quickly reel the mixture, or we can easily mix the liquid as compared to that of, because if we rotate, the mixture inside will mix with each other, like the liquids will mix with each other. The round bottom flask for holding a liquid and should not be heated. In a round bottom flask, yes, you should understand the reason for each crucible. A flat bottom flask is there for holding the liquid but not heating them. A round bottom flask for heated liquid. A crucible is there. How a thistle funnel does not allow the pressure to build up, because what happened? Liquid will slowly add up to, because when you add a liquid, slowly liquid will, because this outlet is very thin, so small amount of liquid will enter the flask and it will react with a solid. So the pressure, the gas will not instantly produce, gradually it will produce. That does not allow the buildup of the pressure of the gas. Otherwise, if whole liquid is added, like acid was added directly, then it will give a gas at a faster rate, so it will build up a pressure. A round bottom flask is there for heating the liquid. A crucible is there for heating solid to high temperature. This is a support for the crucible, like on which we place. Spatula is there to pick a small quantity of a solid. A tripod stand is there, which is used to place the first, before tripod, like on tripod we can place this support for crucible and then crucible. A gauze is there, spread the heat evenly. Basically what happened, like if you place a burner, a Bunsen burner below this, so from heat from the Bunsen burner will not spread out one region, it will be higher. So we use this wire gauze, the net, So when this net will absorb energy, it will uniformly transfer the heat energy. So the whole liquid or whole apparatus will be heated up uniformly. Evaporating dish, for evaporation of the solution we use this. Funnel is there for filtration. Buchner funnel also for filtration. Beehive shell used to collect a gas over water. Like what we do, maybe you have seen this apparatus. We have, say, a container. Then we place this beehive shell. So, and from here the gas from the pipe can enter, and we place a gas jar so the gas will be collected. This is normally done when we want to collect a gas over water. What is the advantage of collecting a gas over water? But it should be for insoluble gas, a gas which does not dissolve in water. Because what happens when the gas is given off, so we can identify that the reaction occur and the gas is being released. Crystallization, this used for crystallization. Normally they are not asking to draw the apparatus, other than filtration is there, but normally they're not asking to draw, they ask to label the apparatus, the parts in paper 6. A wash glass is there for evaporation of a small amount of solution, and a dropper or a teat pipette to measure a small amount of liquid or transfer the small amount of liquid. How we can check a substance is pure or impure? If you want to identify the purity of a substance, there are three ways to check the purity. Number one, we can check the melting point. Number two, boiling point. And number three, chromatography. So to check if a substance is pure, we have to check the melting and boiling point. A pure substance have a definite and a sharp melting point, and if it's impure substance, it will have a melting point will decrease. As a substance is impure, it will have lower melting point and it will have a higher boiling point. So they will have a wider and a bigger range of melting and boiling point as compared to that of pure substance. Normally, the methods which we use to separate the substances, solid from liquid, we use filtration. Solid from liquid, we can also use centrifuging. Evaporation, if we want solid from its solution. Crystallization, if we need solid from solution. Distillation, if we need liquid from the solution. Fraction distillation, if we want to separate liquids from each other. And chromatography, different substances from solution, or separating the colors or identifying the colors. Example, if we want to separate a chalk from water, so what we can do, we can use filtration. What is left on the filter paper is residue. What passes through a filter paper is filtrate. Centrifuging, when we are moving the particles at a high speed, this is done normally for very small solid particles. So when we rotate at a high speed, the particle experience force and they will settle down at the bottom. Evaporation, when we remove all of the liquid from the solution and a solid left behind, we call evaporation. Crystallization, when we remove some of the liquid and concentrate the solution, then cool down, we call this technique as crystallization. If you want to separate mixture of two solids, that can be done by dissolving one in appropriate solvent, then filter one and extract the other from the solution by evaporation. Like, because if two solids are there, we'll check which one is soluble and which one is insoluble. So using a soluble and insoluble, we'll add a appropriate solvent, a solvent which can dissolve the soluble one. Then we will filter to remove insoluble, and we do evaporation or crystallization to obtain the soluble one. A simple distillation, like example, if you want to, if we have an impure liquid, like say a salt solution is there, so we supply a heat energy, this liquid will absorb energy, rises, condenses by the wave condenser, remove the heat energy, and the water inlet is always from the bottom and outlet is from the top. And as a result, what we'll obtain, we'll obtain a pure liquid. But if we are carrying out a fractional distillation is used to separate two or more miscible liquids on the basis of their boiling point. So when two liquids are there, we heat them. The one which is having a lower boiling point will rise. Here is the fractionating column. Once it reaches the fractionating column, having a it's having a temperature regions, like here temperature say 100, 200, 300 and 400. So once the temperature of the vapor is above this temperature, they will rise and condenser remove energy and will collect. The liquid which is having a low boiling point will vaporize first and will collect that. So a mixture is heated, then the wanted substance boil and evaporate. The water inlet, here we push the water that is connected to a tap. The water absorb energy, it passes around the tube, take energy and escape. Even it moves against the gravity, but we are forcing or pumping the water to move from bottom to top. Because when hot water, the water absorb energy, it become hot, so it will rise. Round bottom flask is used for heating a liquid. Flat bottom flask is to hold the liquid. Why specifically we are using a round bottom flask? Because example, if you are not using, for example, if there was no wire gauze, you can use this round bottom flask because it will transfer the heat uniformly. A chromatography, a technique which we use to separate two or more substances from each other or identify or check the purity of a substance. Like if you want to check a substance is pure or impure, so what we will do, we'll take a chromatogram and we will draw the origin with pencil. Why specifically with pencil? Because it will not dissolve in the solvent. Then we will place a sample here, use a suitable solvent. As this chromatogram absorb, the solvent will rise. Along with the spot, if spot rises more, it is more, like example, when I get two spots. So if I am getting two spots, it means it is impure. And which one is more soluble, spot A or spot B? Which one is more soluble? Which substance is more soluble? Substance A or substance B? Substance B is more soluble because it rises to greater, it rises more with the solvent as compared to substance A. And the substance which is more soluble will have a higher RF value or greater RF value. And the RF value is the distance moved by the spot divided by distance moved by the solvent. So the one which is more soluble will have a higher RF value as compared to the RF value of a substance which is less soluble. If it is insoluble, it will remain on the origin. So we can use to separate the substances from each other. We can identify the substance or check the purity of the substance. So this was chapter 2, the experimental techniques. Chapter 3 is atoms, elements and compounds, atomic structure, periodic table. So this is according to the syllabus. Topic 3 about elements, atom and compound. First about the atomic structure. The atomic number is the number of the proton, and atomic mass is the sum of neutron and proton. Inside the nucleus we have neutron and proton, and around the nucleus electrons are revolving. When we show a shells, that's called a Bohr's diagram, named after his work is done for, he did the work for physics as well, but here you're learning chemistry, so this is according to chemistry. The Bohr's diagram, in Bohr's diagram we show the shells. In a Lewis diagram we just only represent the electrons in the outer shell. Then the relative charges for proton, this is a relative, not the exact charge is a comparison. Proton and neutron have the same charge. Proton and neutron have the same charge. Proton and neutron have the same mass, not the charge. And electron is the lightest one, 1/1836, the relative mass. But when we compare the charge, proton and electron have the same charge and neutron does not have any charge. The proton number is the number of proton, nucleon number is the sum of proton and neutron. So use proton number and the simple structure of atom to explain the basis of periodic table with special reference to element 1 to element 20. So you should be able to arrange the element and draw their structure from hydrogen till 20th is a calcium, so hydrogen till calcium. So in a periodic table, elements are arranged in order of atomic number or proton number. So element with a similar chemical properties are in the same vertical region, which we called a group. And if they have the same number of shell, they are in the same periods. Elements are arranged in order of increasing atomic number in a row, which we call period, and which is similar properties are same in a vertical, which we call that as a group. So elements in the group will have the same number of valence electron in the last shell, and the period means the number of shells. The term isotopes means atoms with same atomic number but different atomic mass. We call them as isotopes. And isotopes have the same chemical properties because they have same number of electron in the outer shell, and the number of electron in outer shell are responsible for chemical properties. And they have the same number of protons, so they are still classified as the same element. But the only thing which is different is the neutron number is different, or nucleon number is different. There are two types of isotopes. One is radioactive, another one is non-radioactive. Radioactive means one which is emitting out radiation such as alpha, beta and gamma. So one medical and one industrial use of radioactive isotope. Medical use to sterilize equipment to kill bacteria, and as a tracer to identify any blockage in the arteries. This can be used. Industrial, it is used in smoke alarm, as well as a tracer means it can also be used to identify any blockage in the pipes or blockage or leakage in the pipe. Then in the first shell arrangement of electron, the first shell maximum you can have 2 electron, second shell 8, and third shell up to 8. For first 20 elements, you are doing this for first 20 elements only. If it is having 1 electron in the outermost shell, it will be group 1. If 2 electrons, it will be group 2. And if it has a complete outer shell electron, we call this as a noble gases, because they are more stable, they are not reacting. Commonly their compounds are, we don't find their compound. Reactions are there, some of these group 8 elements react. You will learn that in A levels, that there are compounds which these, like there are compounds consist of xenon as well, xenon and fluorine. So they are, but for O levels you will consider them they are stable and unreactive. What is the definition of relative atomic mass? Relative atomic mass means it is a mass of element which is compared with the 12th part of carbon. We call that as relative atomic mass. Then the bonding, we have in the describe a difference between element, mixture and compound. So element is a pure substance which contain identical atoms. A mixture, two or more substances not chemically combined together. Compound means two or more elements chemically combined. Metals, they tend to form a positive ion, and we'll find them found to the left and towards the bottom of a periodic table. So most of the metals are on the left and bottom, and non-metals on the right hand side of a periodic table. You will find these non-metal. Alloys, what are alloys? Alloys are the mixture of the metal, and generally alloys are harder compared to that of pure metal because the layers cannot slide over each other. Metal and electron is there. What kind of bonding? Metallic. Metal and non-metal, ionic, and non-metal and non-metal, it will be covalent. So what happened in ionic bond? The electron actually transfer from metal to non-metal. Positive ion is known as a cation and negative ion is known as anion. So if group 1 is reacting with group 7, group 1 is having 1 electron in the outermost shell like sodium, and group 7 such as chlorine. So there are 7 electrons. So metal tend to lose electron, non-metal tend to gain. So sodium will get positive charge and chlorine get negative. And these unlike charges held together by a strong electrostatic force, arrange them in a lattice. We call that as the lattice of the ionic compound. So they have a strong force of attraction and required lot of energy to separate these ions. That's why ionic compounds have high melting points. Covalent compounds, they're formed by sharing of electron. It can be a simple, it can be a giant. Giant means like lot of atoms are there within the structure, such as diamond, graphite, or silicon 4 oxide. The diamond is having a tetrahedral structure. Graphite is having a hexagonal structure. But because in graphite there's a one weak force is there between the layers can slide over each other, so it is generally soft and slippery. And in silicon 4 oxide, this is also a giant covalent compound, but this is a compound. Diamond and graphite are element which contain carbon. The uses, you have to go through graphite for lubricant because the layers can slide over each other, conduct electricity because of the free electron in this ring. And diamond is the hardest substance known because of its rigid for cutting tools. The similarity between the diamond and silicon 4 oxide, both are hard, both have high melting and boiling point, insoluble in water, and does not conduct electricity. Simple covalent bond by sharing of electron. If it is group 1, group 4, sorry, group 4, 5, 6, or 7. So group 4 will share 4 electrons, this 5 will share 3, 2 and 1 electron. So oxygen belongs to group 6, so it will share 2 electron, and hydrogen is having only 1 electron, so share 1. This is a structure of a water molecule. And the metallic bond, the bond which is formed between the positive ion and the delocalized electron, and this electrostatic attraction is strong. In metallic, we have a lattice of a positive ion, but in ionic, we have a lattice of positive and negative ions. So this is a summary of this chapter. Ionic compound, they have a basically bonding results of attraction of positive and negative ion, and they have high melting point, does not conduct electricity in solid, can conduct electricity in molten or aqueous state. Diamond, graphite, and silicon 4 oxide. Comparison is there, bonding, arrangement, properties, how they appear or look, and what are the uses for them. So today we discuss 3 chapters. I will share these 3 chapter sheets with you, the revision sheets, so you can also go through. Any question related to the class? Okay, so I'll end the session and share this.